Hello everyone, I am Navayuktha. Here we discuss about the topic is speed control of induction motor. The flow presentation is introduction, requirement of speed control, types of method to control the induction motor, advantage and disadvantage, and the conclusion. Various methods of controlling speed of induction motor can be visualized by this in this equation. Ns equal to 1 minus s power ns. Rotating magnetic field. The constant magnitude is produced the rotating with the speed. Ns equal to 120 f by p. Where ns is the synchronous speed, where f is the frequency, and p is the number of volts. There are many types of speed control methods. They are by changing the supply frequency, applied voltage, by pole changing, by varying the rotor resistance, by injecting a EMF in the circuit, and a cascading of motors. Requirement of speed control is speed control means the drive speed is desired as a process to maintain the different process parameter at different load and energy saving. Speed control is different concept from speed regulation where there is natural change in the speed due to the change on load on the shaft. Since speed control either done is manually by a operation or by means of some of automatic control devices. Low speed starting requirement. These are the requirement of speed control. Methods of speed control of induction motor. These also stator voltage control, stator frequency control, stator current control, E by F control, static rotor resistance control, stator voltage control, synchronous speed, where Ns is a synchronous speed equal to 120 F by P, where F is a frequency and P is a poles. A torque equation T is directly proportional to W square. The, the given chart is also shown in the figure. Here the rotor resistance is R2 is constant and the slip is small to Sx2. So small that can be neglected that for T proportional to Sc2 power 2 where E2 is a rotor induced EMF and hence T is proportional to E power 2. This method is easy and so simple. Still rarely use this method. A large change in the supply voltage is requirement for relatively small change of the speed. Large change in supply will result in large change in flux density, hence disturbing the magnetic condition of a motor. Variable terminal voltage control of induction motor is shown in the figure. This is a frequently controlled method. By changing the frequency, we can control the speed of above and below the rated speed, offering high range or low range of the speed control. Stator current control method. Starting torque of an induction motor is Ts. It is proportional to a square of the stator current, so that it is independent to supply frequency. and it is independent to rotor resistance. A constant three-phase induction motor can be obtained a three-phase CSI. The inductor converter DC voltages constant current sources. The CSI regulated the output voltage frequency, the output frequency, and hence torque of induction motor. How to speed control using VFD? VFD is variable frequency rectifier, DC bus, and IGBT are used to control the speed. Rectifier. Rectifier used in a VFD control in converter AC to DC. Rectifier normally the rectifier is used to convert AC to DC. So that here rectifier is used VFD to convert AC signal to DC signal. DC bus. DC output power follows through the DC link through a inverter input. Then the IGBT. Insulated gate bipolar transistor is known as IGBT. It is a common choice of VFD controller. The IGBT through use control name is pulse width modulation. The figure is also shown but not a clear. Then V by F control. Then voltage and frequency control. Then the advantages and disadvantages of this. Advantages is easily speed control. Very less maintenance and more power and save more energy. Reduce thermal and mechanical stress. Then motor AC motor is less expensive so that we can use this. Provide low speed starting facility. These are the advantages of this. Disadvantage. Power converters for AC motor are more complicated. Power converters for AC motors are more expensive also. Then the generate harmonics are disturbance. The conclusion of a speed control of induction motor is in case of squirrel cage induction motor, the slip cannot be increased above a certain limit. The operating speed range is very less. By applying the V by F control, we can get the large operating range by keeping this V by F ratio constant. So that we are using V by F control, we can get large operating range. Thank you.